In this video, we'll be building the airblade transformer ultralight. It's a 5-inch long-range drone capable of flying more than 20 minutes on lithium-ion batteries. The frame weighs only 46 grams, and the top and bottom plates are 2 millimeters, while the arms are 3 millimeters. We'll be using the Beta FPV Toothpick F405 all-in-one flight controller and ESC, the Caddx Nebula Pro DJI FPV video transmitter, the TBS M8 GPS unit, the Airblade Superman 1905 2400 kV motors, and the TBS Crossfire Nano receiver. The frame assembly is pretty straightforward. The arms mount under the base plate, and you use this smaller brace plate to secure them in place. The press nut on the base plate points up, and the press nuts on the brace plate point down. Pay close attention to the tips of the arms. It's easy to get them flipped upside down. Once you've screwed the arms in with the 4 screws, you just need to finish it up with a screw straight up the middle press nut. Use the 6mm M2 screws to mount the motors to the arms, and always double check that none of the screws make contact with the motor windings. You might also want to use some blue Loctite on these screws. Next, we need to get these little vibration dampeners on the flight controller, and a little trick I found is to wrap some dental floss around them and use that to pull them through. Otherwise, it can be a real pain to get this done. Now we can solder the power lead to the flight controller, and it's great to use some of this fun tack to hold everything in place. Here, I flipped the board upside down so I could solder the power lead to the top of the flight controller. Now let's mount the flight controller to the frame. Use the included 10mm M2 screws. And here I only used 3, but if you can squeeze one more between the power leads, it'll be helpful. Now use some zip ties to prepare the motor wires for soldering. Stretch them out flat across the arms and pull them nice and tight so you don't have any slack. This will really help when you need to cut them to length. Alright, it's time to solder. This is definitely the most challenging and most tedious part of the whole build, so just take your time. I usually like to brush the pads with a flux pen before adding just a tiny bit of solder. Don't add too much or it'll overflow to the next pad. Cut each wire to length as you go, and don't forget to tin the tips. You can leave the zip ties on if you'd like, but I prefer to replace them with some cloth tape. It looks nice and helps prevent tree branch snags. You can wrap one strip around the front arms and a couple strips around the rear arms. Next, let's add the GPS. We'll be mounting it in this 3D printed accessory, and these standoffs can be a little fussy, so you might want to insert them first before you mount them to the frame. Screw only one side on at first so you can swivel it out later to install the air unit. Now let's take the wires and pass them through the little hole in the TPU holder so we can solder them to the flight controller. Solder the wires to the 5V ground, TX1 and RX1 pads. The green wire goes to TX1 and the blue wire goes to RX1. So I'll be using a Crossfire Nano receiver, which means I don't need the S-Bus wire from the Caddx Vista. If you're using the DJI remote, you'll want to keep this wire and solder it to the S-Bus pad on the flight controller. And either way, you don't need the extra black ground wire. Otherwise, you absolutely need the power, ground, RX, and TX wires. Mount the air unit using the 20mm M2 screws. Now, these don't come with the frame, so you'll need to order the M2 screw and nut kit linked in the description. Now, you want to stack a pair of M2 nuts to give the air unit some breathing room underneath. When mounting the air unit, make sure the antenna bracket is toward the back. Wrap the wires underneath and slide it down over the screws. Secure it with a set of M2 nuts, and the nice thing about this flight controller is that it has a plug for the air unit, so just plug it in and lay the wires down neatly. Finally, we need to attach the antenna. Swing the GPS out of the way and remove the corner screw to release the bracket. Pass the antenna wire through the GPS mount and carefully plug it in. Now for the hard part, getting this bracket back on. Make sure you've got it hooked on the little peg, and it may take a little force to get it back on there. Screw in the other standoff and seat the antenna. Now we'll wire up the Crossfire Nano. You can skip this step if you're using the DJI remote. Use the plug that came with the flight controller and solder the wires as shown. Since we're using Crossfire, we'll need to bridge these 2 pads toward the front of the flight controller. Just add a glob of solder until they're connected. Plug the receiver in and we're done. Find the shortest M2 screws in the kit and use those to attach the side plates to the camera. But don't tighten them down all the way though, you'll probably need to keep them a little loose to slot the camera mount onto the frame. Finish by adding the remaining screws and standoffs to secure the top plate. We'll be mounting the antenna vertically, so remove one of the caps and slide it through the slot on the GPS mount. It can be a tight fit, so you may want to pass a screwdriver through first to loosen it a little bit. Add the shrink tube to the receiver and pass the antenna wire through the top plate before you plug it in. Slide the shrink tube back over, and now let's bind it to our radio. Plug a LiPo in, and if it's a fresh receiver, it'll go into bind mode immediately. Otherwise, you need to press the button after you power it on. Put your radio into bind mode, and you should get a receiver update, which may take a few minutes, but once that's complete, you're all set. To secure the antenna, you'll need to screw this little bracket into the GPS mount, and since I used longer screws, I found it better to flip it upside down to keep the screws from poking out the bottom. There's a lot of loose wires in here, so you might want to wrap it all up neatly with a zip tie. Here I cut some grip to size to use as a battery pad. This is optional and you need to buy it separately, but you can add a standoff above the camera to use as a naked GoPro mount. Now the GPS will pop out in a crash, so you want to secure it with some double-sided tape. And finally, you need to zip tie the battery lead to the frame. This helps relieve stress on the flight controller if you eject your battery during a crash. Before you put the props on, you'll need to plug this into your computer and go through the Betaflight configuration process. Check the description below for a link to rotorbuilds.com for step-by-step directions, as well as photographs and a comprehensive part list. Now let's see how it weighs in. 194 grams dry. With a 2000 mAh lithium-ion pack, it weighs 388 grams. With a 4S 650 mAh pack, it weighs 273 grams. And with a custom 3S 2600 mAh lithium-ion pack, it weighs 343 grams. Finally, here it is with the Beta FPV SMO 4K digital camera. With that, it weighs 232 grams dry. And with a 650 mAh 4S LiPo, it weighs 312 grams. And that's it. This is a great cruising rig with some pretty decent power for light acro. It'll fly for more than 20 minutes on a lithium-ion battery and anywhere from 5 to 15 minutes on a 4S LiPo. It's a 5-inch rig, so technically it can carry a full-size GoPro, but you'll take a big performance hit. You're much better off running a naked cam like the SMO 4K or a naked GoPro. Be sure to check my written guide on rotorbuilds.com for more detailed build instructions. I hope you enjoyed, and please subscribe for more FPV related content.